Hello all, and welcome to Module 9, dealing with the first of two modules, dealing with thermodynamics. And in Module 9, which equates to Chapter 9 in your text, we're dealing with fluids, fluid dynamics, pressure, and so forth. And first let's talk about fluids. Fluids in general are constituted by liquids and gases. When I say fluids, people typically think of liquids, water and so forth, but actually gases are also considered fluids because there's a lot of space between molecules. Fluids float one layer on top of another on top of another. Both liquids and solids do. I'm sorry, liquids and gases do that. Solids do not. Solids are much more stringent in that sense. Now, with fluids, we're going to talk about a couple different things. First off, pressure. Pressure in general is just force divided by the cross-sectional area that force is being applied. For instance, if you have a sharp knife or a dull knife, you're applying a force when you're cutting, but the difference between a steak knife and a butter knife is the surface area of the blade itself. In other words, the sharper the blade, the easier it cuts because you can apply a greater pressure because you're reducing the area, which causes an overall increase in pressure. So to calculate pressure, it's just force divided by area. The area of the force is being applied, and we measure it in pascals in the metric system. It's actually newtons over square meters. That is equivalent to 1 Pascal. Empirical units, PSIs, pounds per square inch. Pounds measure force per square inches is a unit of area. So that's a comparable unit. Now, there are going to be three principles in this chapter that we talk about. The first one is Pascal's principle. And that simply states that any change in pressure of a fluid is transformed uniformly throughout the fluid. So say, for instance, this room is filled with air. If I change the pressure of the air in this corner right here, it changes the pressure of the air in the entire room. This is the whole principle behind hydraulics and how hydraulics work. In fact, I have an example that's going to explain just that. Say we work with the hydraulic jack system, like they're using car garages to lift a car. You have an input cylinder and you have an output cylinder. What happens is a force is applied to the input cylinder, and that creates a change in pressure of the fluid contained in the cylinder, usually hydraulic fluid. Now that changes the pressure of the fluid inside this cylinder and the fluid in that connecting hose and the fluid in the output cylinder. So that same change of pressure that we're experiencing in the input cylinder, the fluid in the output cylinder experiences. That output cylinder has an output piston that goes up as opposed to down, and that change in pressure causes an output force, which lifts your car. So what I've done is I've created an example, mathematical example using that. One that's very comparable to what you're going to be using in your studies. Now, if I give an example where the input cylinder has an input diameter of 0.4 meters, output cylinder has an output diameter of 1.2 meters. You're applying a 200 Newton input force. What's our output force? And what I'm going to show you can work in either way. If I'm giving you an input force and you're looking for the output force, or if I'm giving you the output force and you're looking for the input force. Step one is to calculate the surface areas of the cylinders. Since these are cylinders, they're circular, the surface area basically is the area of a circle. So it would just be pi r squared. Now notice I just went ahead and did both of them here. So for the input cylinder, that's this one over here, I'll give you the diameter is 0.4 meters. We need the radius, so we have to cut that in half to get 0.2 meters. So pi times 0.2 meters squared gives us about 0.126 square meters. And might as well just do the output cylinder while we're doing it. It has a diameter of 1.2 meters, so it has a radius of 0.6 meters. So we have pi times 0.6 meters squared, which gives us about 1.13 square meters. So step one is to get those two areas calculated. Step two is to find that change in pressure. Now in this case, I give the input force, so we're going to use the input cylinder's information. If you're given a necessary output force, say for instance you have a car that weighs 10,000 newtons, you have to lift it, then you use the output cylinder in order to calculate it. But since we have the info over here, we're going to use the input. So we're finding our pressure. Pressure from the input cylinder is the input force divided by the cross-sectional area of the input cylinder. So we have that 200 Newton input force, which is given, divided by the 0.126 square meter input area, which we calculated up here, we get about 1,587 and change pascals. That is the pressure change that the fluid in the input cylinder is experiencing. But since that same fluid is connected via the hose to the output cylinder, this fluid in here is experiencing the same pressure change. So in step three, we're going to calculate the force. In this case, it's going to be an output force. because that's what we're asked for, but it's also what we don't know here. We have the same pressure change with a different size cylinder. It's going to produce a different size force. So if we rearrange the pressure formula to get force, force is simply pressure times area. So you take that pressure change that we calculated previously of 1,587.3 pascals times the output cylinder's surface area, which is 1.13 square meters, you get an output force of 1,793.65 newtons. We started off with 200 newtons. We ended up with an output force of almost 1,800 newtons. That's 9 times as big. That's the whole idea behind hydraulics. You can get a much greater output force with a relatively small input force. It's all in relation to two things. One, the pressure change of the fluid, but secondly, the difference in diameters of the cylinders. And this is how you can lift very, very heavy objects with, relatively speaking, very light force.